Make a circle round and round, round and round. Hello everyone, welcome back. Today we are starting with the chapter Circles of class 9. Alright, so here in this chapter, you are going to learn all the definitions, all the theorems, and then we are solving some important questions which are previous year questions. Okay, so by at the end of the video you will be ready with this geometry chapter. Circles will be your strongest topic, and whether you are preparing for your midterms or some final exams, then this is going to be really helpful. So watch this video completely. Okay, you can simply jump to the topic which you want if you already understood the topic. So let's start with the definitions first. Now the circle is a set of the points, right? These are points which are at the same constant fixed distance from here. Okay, so this center is the fixed point, and the distance from the circle to center is called the radius. All right, and when I have 2 points, okay, on the circle, when I am joining them, the line segment is called the chord. Now when the chord is passing through the center, it is called the diameter, right? This part of the circle, okay, first of all understand the circle, okay, that is dividing the entire plane in 3 parts. First is the interior part, this whole interior part, okay. The second is the circle itself, which is nothing but the boundary or the circumference of the circle, and the exterior part. All right, now we are talking about this interior part of the circle made by this chord. So it is called as it is the smaller part, it is called the minor segment, and the remaining bigger part is called the major segment. Remember, for the diameter, the circle is making the semicircle, right, which we call the semicircle. So that's a segment of the circle, right? Now if we think about a pizza slice, so that is nothing but the sector of the circle. So just imagine a pizza slice small, so that's a sector of the circle. All right, so it's a minor sector because it's a small part, and the remaining part, okay, this remaining part is nothing but the major sector. All right, so when I turn the circle, okay, at any angle, it gives me the same figure, right, without changing anything. So it has infinite rotational symmetry, and it has infinitely many line of symmetries as well. All diameters gives a line of symmetry, right? So that's very useful concept. Now coming to the very important concept again. So I can draw infinitely many circles, okay, with different sizes from a given point in a plane. So if you see here, the point is given, okay, and I can draw many circles, right, many circles through this point P. Okay, now what if I am given 2 points? So I can draw again infinitely many circles, but here remember that when I join AB, okay, and if I think about the perpendicular bisector of AB, then all the centers of this circles lie on this. Okay, very important thing. Now there is no circle which is passing through 3 collinear points. So here if you see, point A, B and C are 3 collinear points, and I cannot make a single unique circle which is passing through this collinear points. Now what if point A, B and C are non-collinear points? So if you see here in the figure, point P, Q and R are 3 non-collinear points, okay, and there is one unique circle. Unique means what? One and only one circle which is passing through these 3 points. Now this circle is called the circumcircle. Okay, so circumcircle is the circle which is passing through the vertices, or I can say 3 non-collinear points. Okay, now how do I get the center of this? So when I join these vertices, okay, I get a triangle. And when I think about the perpendicular bisector of each side of this triangle, okay, these are the perpendicular bisectors. When I think about this, when they meet, the point is called the center, or specifically circumcenter. So this is my circumcenter. If I'll just take the distance to center to this vertex, okay, that's nothing but the radius, and then I can draw the circle, alright, which is called the circumcircle. Now, very important point to remember, okay, regarding circumcenter. This comes in MCQs or objective type of questions. So, for acute angle triangle, the circumcenter lies in the interior part of the circle, okay. For obtuse angle triangle, the circumcenter lies of the exterior side of the triangle, if you see here. And for right angle triangle, the circumcenter is the midpoint of the hypotenuse. Very important point, okay. So, just make a note for this, okay. Now, we start with our theorem 2, okay. So, the theorem is saying that the equal chords of the circle subtend equal angles at the center. Now, first of all, let's understand what do you mean by angle subtended at the center. So, this chord is there, okay, chord AB. Chord AB, when I join with the center, so I get this BC and AC, and this angle ACB, okay, which is formed here, is called the angle subtended by the chord, okay. So, ACB is the angle subtended by chord AB, and angle DCE is the angle subtended by chord DE. Now, we know that the given is what? The given is two chords are equal, right? Equal chords means what? AB and DE are equal chords, okay. So, now I want to prove that this angle ACB equals to angle DCE, okay. Now, for that, I'll just take these two triangles, okay. The proof is what? I'll just take the two triangles, triangle ACB and triangle DCE, right? Triangle DCE. Now, I know that AC equals to DC, correct? Why? AC equals to DC because they are radii, right? Then I know that BC is equals to CE, correct? Again the same reason, BC is equals to CE because they are radii. And AB equals to DE, they have given this. So, AB is equals to DE. This is given to me. So, I can say that by SSS rule, these two triangles are congruent. So, by SSS rule, I can say that triangle ACB congruent to triangle DCE, correct? And by CPCT, I can say that angle ACB equals angle DCE, okay? This is by CPCT. Congruent parts of congruent triangles. So, this is how I got this angle this angle subtended by the equal chords is equal. Alright. Now, the converse, okay, vice versa is also true. So, vice versa is what? The chord subtending equal angles, then the the chords are equal. We have to prove that equal in length. So, here given is what? Given is angles are equal. So, ACB equals to DCE, correct? This is given and I want to prove that. AB is equals to D. This is just opposite to the theorem 2, right? So, now see again AC is equals to DC, this is radii, okay. BC is equals to C, again radii, right? And angle, this angle is given same. So, I can apply SAS rule, okay, SAS rule. So, to tell that these two triangles are congruent, and by CPCT, I can say that AB is equals to D. Alright. So, in the second theorem, we apply the SSS rule, and in the third theorem, which is converse of this, we applied SAS rule. Okay, so remember, very important tip, equal chords and equal central angles always travel together. Okay, whenever you see there are equal chords or equal central angle, apply this theorem to solve the problem. I hope you get this. Now coming to the next theorem. So what they are saying, the line joining the center to the midpoint of the chord is perpendicular to the chord. Now means what? So here we are given a circle with center C, a chord is given AB and M is the midpoint. So I am given that, okay, let me just write what is given to me. So I am given that M is the midpoint, M is the midpoint of AB. Alright, and I want to prove that CM is perpendicular. See what they are saying, line joining the center and the midpoint. So line joining CM, I mean they are talking about CM. So CM is perpendicular to AB. This I want to prove. Again, what I'll do, I'll just join AC and BC. Now I'll take two triangles. Okay, which two triangles do we take? Triangle ACM and triangle BCM. Correct, BCM. Now here AC is equals to BC. Why? Yes, because they are red eye, right? Then CM is common. CM equals to CM, which is common, right? And what I can say, AM equals to MB. AM equals to MB. Why? Because M is the midpoint. M is the midpoint. So side and side again. So using SSS rule, what I can say, these two triangles are congruent. So triangle ACM congruent to triangle BCM, right? They are congruent, and therefore by CPCT I can say that the corresponding angles, so I am talking about angle AMC and angle BMC, they both are congruent, but they are linear pair angles, so they are also congruent and they are 90 degree. Hence CM is perpendicular to BC, right? Now the converse of this is also true. Okay, so if CM is perpendicular on BC, then we have to prove that M is the midpoint. So we can easily prove using SAS rule again, right? So this is how we can solve this. Now this perpendicular distance, okay, I can easily found with the Pythagoras theorem. So to get the chord length, okay, if I want to find the chord length, that is a chord length C, if I'll just tell it is a C, small c, okay. If the radius is R, this distance is D, okay, then I can apply the Pythagoras theorem and I can find this, okay, this part MB, okay, MB or AB, sorry, AM is equals to square root of R squared minus D squared, and then as the M is the midpoint of this chord, I can make a double of this to get the chord length. So midpoint and the perpendicular comes a pair, okay, just remember this. So we'll start with the important theorem of this chapter, okay, theorem 9, okay, central angle theorem, and they are saying that angle subtended by the arc at the center. So this is the arc AB given, and the angle subtended by the arc at center is angle C here, okay, is double the angle subtended by it at any point on the remaining part of the circle. So a point D is there on the in the remaining part of the circle, and this angle ADB is angle subtended by the arc, okay. Now we have to prove that, okay. So we have to prove that this angle ADB is double of angle ACB. Alright. Now to prove it, let's understand this. See, if I'll just take this triangle, okay, this is the isosceles triangle. So this angle and this angle, they both are equal. I'm talking about these two angles, okay. So if I'll take this as 1, okay, this angle as 2, this is angle 3 and angle 4. Now this also angle 1, this is also angle 1 and this is also angle 2 because the isosceles triangle. Now we have learned one important property, which is external angle property. Okay, what it says, if I have this external angle 3 over here, then the angle 3 is the sum of the far two interior angles, which is, let's say here 1 and 2. Okay, so I know that it is 1 plus 2. This we already know. Okay, now using this result, what I can do is, in this triangle, triangle DCB, okay, triangle DCB, what I can say that this angle 3 is equals to 1 plus 1, which is twice of angle 1. Okay, same way if I'll consider the other triangle, okay, the triangle I'm talking about, this triangle, and this is the exterior angle. Okay, so applying the same property, I can say that angle 4 equals to twice angle 2. All right, now I'll add these two results. So what I'll get if I'll add them, angle 3 plus angle 4, okay, is equals to 2 times angle 1 plus angle 2. Now I'll just replace this numbering by the naming of the angle. So angle 3 plus angle 4 is nothing but the angle ACB. So I can say that this is angle ACB, which is nothing but 2 times, okay, angle ADB. And this is what we have to prove. I'm sorry, I have to write here this as ACB and ADB. All right. So the central angle is double of the segment angle. Okay. So I can say that the central angle is double of segment angle. Right. I hope this is clear now. All right. Now using the same theorem, I can prove two important, very important result. Okay. Very important. Most of the question occurs on this. Okay. So the first one is what? The angles in the same segments are equal. Now here angle A and angle B are the angles in the same segment, and they are equal. How it is so? So I know that angle POQ, which is the central angle. Okay, POQ is equals to 2 angle PAQ, right? And same way angle POQ is 2 times angle PBQ using theorem 9. Okay, so using this 2, okay, I can say that angle PAQ is equals to angle PBQ. So angle in the same segment are equal. Now what if we are talking about the semicircle? Okay, the arc is the semicircle, the chord is the diameter. So in this case, this angle is 180 degree straight angle. So half of that, which is 90 degrees, so angle C is 90 degree right angle. So angle in a semicircle is a right angle, which is again very important result. Now coming to again one important point, which is concyclic points and cyclic quadrilaterals. So the points which are on the same circle are called the concyclic points. Okay. Now from this definition, we have to prove theorem 10. Now theorem 10 is saying that a line segment AB, okay, joining 2 points AB. So AB is there, okay. Subtend the equal angles. So angle ACD equals to angle ACB equals to angle ADB. They have given, okay, this is given. And we have to prove that this fourth point D is on the circle, means they are concyclic points. Okay, now we prove this theorem by contradiction. Okay, contradiction is what? We'll assume that D is not on the circle. So let D is not on the circle, right? So we have these two cases. This is case 1 and case 2. Okay, in case 1, what we have taken, the D is external point. In case 2, we have taken D is the internal point. And when I extend, when I just take one more point E, which is on the circle, I have the result as angle ACB is equals to angle AEB, right? And as this is the external point, I can say that angle AEB is greater than angle ADB. But this is not possible. Why? Because they have given that ACB is same as ADB. So this is not possible. Correct? Same way, if I'll take D in the interior part of the circle, then in this case, what I can say, angle ADB, okay, which is greater than angle AEB, okay, and angle ACB is equals to angle AEB. Again, this is not possible. Why? Because we are given that ACB is same as ADB. So this is also not possible. So contradiction is wrong. So the assumption is wrong. Is incorrect. Okay. So D is on the circle. Correct. I hope you get this one. Now we are going to solve theorem 11, okay, which is saying that it is based on cyclic quadrilateral, okay. Cyclic quadrilateral again, when the points are concyclic on a same circle, okay. So it is saying that sum of two opposite angles of a cyclic quadrilateral is 180. So the given thing is what? The given is, we are given that quadrilateral ABCD is cyclic, okay, is cyclic. All right, means all the vertices on the circle. Now I have to prove that angle A plus angle C is 180 and the remaining two angles are also 180. Okay, so again I'll take the segment angle property. Now if you think about this angle, okay, here, and this angle, so angle, central angle and the segment angle. So angle BOD is 2 times angle BCD, correct? And now if I'll think about this angle, so the angle A is on the other side of this angle, so we have to take the reflex angle as a central angle. This is very much important concept here, okay? You must know that. See, just understand that. See, when I take angle C as a segment angle, then this angle BOD is the central angle, okay? This is clear, which we already done, okay? Now here, if I'll consider angle A, then I have to take the central angle as this, okay? The reflex angle of angle BOD, okay? So what I can say, reflex of angle BOD is equals to 2 times angle BAD, correct? Now when I add them, I know that BOD plus reflex of angle BOD, this gives me 360, okay, when I add them. So I'll get 2 times angle BCD plus angle BAD, correct? And now divided by 2, I'll get angle BCD, which is angle C, okay, plus angle A is equals to 180 degree. So this is what we have to prove, right? So I can say that the opposite angle of the cyclic quadrilateral are supplementary, okay? And as the sum of the all angles in a quadrilateral is 360, the remaining two angle is also supplementary. This and this, correct? This. All right. Now converse of this is also true. So if the sum of two opposite angles is 180, then it is the concyclic quadrilateral. Correct? So this is what all the theorem says. All right. Now we'll solve some important questions. Okay, exam based questions, so that you can do practice and your circle chapter will be thorough. So the first question is very easy. Okay, in a circle the chord is 5 centimeter away from the center, so I'll just quickly make a circle. Okay, and the chord is 5 centimeter away, so here this is 5 centimeter. Okay, if the radius of the circle is 13 centimeter, this is 13. So I need to find the length. So let's say this is C, this is A, this is B, and M. So I know that if I'll take this triangle, I know that this is perpendicular over here. So AC squared equals to CM squared plus AM squared, right? And I want to find AM squared equals to 13 squared minus 5 squared, which gives me 12. Okay. So AM squared equals to 12, and therefore AB, okay, which is the chord. So it is double of this, which is 24 centimeters. So this is my answer, right? Okay. Now an arc of a circle subtend an angle of 70 degree at the center. So I'll quickly make a circle. This is the center. Okay. If I'll just think about the arc AB, okay, this subtend angle 70 degree over here, center. What the measure of the angle subtended by the arc at the point of the circle. So here it will make the angle, okay, and we need to find this. So I know that this is half of this, correct? So angle ADB is half of ACB. This is theorem, okay, which we learned, and this is what? 35 degree. All right. Okay. Now moving to the third question. Okay, quadrilateral PQRS is inscribed in a circle. So basically it is a cyclic quadrilateral they are talking about. So if I just make a cyclic quadrilateral, okay, so P, Q, R and S, these are the points. Angle P is given as 2x plus 10 and angle R is given as 3x minus 20. Now I want to find the measure of value of x and the measure of P and R. So P and R are the opposite angles. So I know that the sum of these two, okay, angle P plus angle R equals to 180. All right. So 2x plus 10 plus 3x minus 20 is 180. While solving this, I'll get 5x equals to minus 10 over here. That goes on the other side. So 90. And then x equals to 38. Okay. When I put x equals to 38 here, I'll get this as 86 and this as 94. Correct? So this is how I can solve this question. All right. Okay. Now this is one important question. Now two parallel chords are given, okay, with two different lengths and on the same side of the center. We need to find the distance between them. So see, first of all, understand that if I have a circle, okay, the center is over here. If I talk about the parallel chords, one chord is here and one can be here when they say the opposite side, okay, opposite side. Here in this case, they are saying and the same side. So I have to consider this case, okay, where the center is there, one chord is here and the other chord is here, okay. Now, we know that the longer chord has the shorter distance, right? So here 24 centimeters. So I can say that AB is equals to 24 centimeter. Okay. And CD, let's say this is CD, has a 10 centimeter length. Okay. This is my center O. If I draw the perpendicular, I can make M and N over here. All right. And I can join the radius. So now I'll take the, and I have given Mn, okay, Mn equals to 7 centimeter, all right. Now if I'll take Om as Y, okay, and OR, the radius R. So I know that r squared equals to OM squared plus AM squared. Now r squared equals to OM is y squared plus AM, which is half of AB. This gives me 12 square. Okay. The other triangle, if I take CON, then I know that r squared equals to 7 plus y whole squared plus half of CD, which is 5 squared. So I know that this is r squared equals to 49 plus 14y plus y squared plus 25. And I can put this value. So I have r squared equals to y squared plus 144. This both are r square value. So I can put it over here. Y square plus 144 equals to 74 plus 14y plus y squared. Y squared will get cancelled out. And when I simplify, I'll get 14y equals to 70 and y equals to 5. Okay. So once I get y, I have the value y, so I can find r, which is nothing but 13 centimeter. Okay, by putting it over here. Okay, so this is nothing but my radius, what they are asking us. All right. So read the question carefully because they have given same side. If it is opposite side, then the distance will be added up because this distance plus I have to do this distance. Here the distance is subtracted. Okay, remember this. So we have learned whole the chapter, okay, starting by definitions, okay, different definitions we learned, theorems all we proved, okay. So you are thorough with the circle chapter, but we need rigorous practice, okay. So practice these questions, and these are some practice questions which you can solve and write the answer in the comment box. If the answer is correct, I will give you heart, and if required, I can give you more practice worksheet as well. Okay. Thank you for watching the video. See you in the next video.